We introduce ScanQA dataset for 3D question answering task and the baseline model for this new task. 3D QA is the task of answering questions on the 3D scene. The input for 3D QA is 3D scan of the indoor house scene, such as in the point cloud format, and a textual question for the environment. To answer the question, the model first localizes the questioned objects from the 3D scene. Next, the model predicts a textual answer for the question. Thus, the model predication is a 3D bounding box representing the location of the object and the answer to the question. In performing this 3D QA task, we created the ScanQA dataset, which is based on a large 3D indoor scene set of the ScanNet dataset. We collected new question-answer pair annotations for these scenes. Based on these auto-generated QA pairs from the ScanRefer dataset, we annotated the plausible question-answer pairs with Amazon Mechanical Turk. 3 answers were collected for each question in the validation and test sets, allowing robust QA evaluation. The video on the left shows the annotation website we created to collect the data. Overall, we collected over 40,000 questions in 800 indoor scenes. We also confirmed over 30,000 unique questions. Our dataset covers various types of questions, such as what color, where and how many, for numerous indoor objects. We also proposed a baseline model for the 3D QA task, the ScanQA model. The ScanQA model uses a feature extractor of VoteNet as the 3D point cloud encoder to estimate the bounding boxes for objects in the environment. Next, the language and 3D features are decoded by a transformer to represent the features of object proposal with self-attention and cross-attention, and the two features are fused together. Finally, the fused features are used in MLP to obtain 3 outputs: answer classification, object classification, and object localization. The results of the question answering. We use the 2 evaluation methods, EM at 1 and EM at 10. We compared ScanQA to 2 different methods, a 2D-based method and a 3D-based method. The 2D-based method used images taken in the environment and input into the VQA baseline method, called McCann, to measure the accuracy of the question answering. Comparing ScanQA and the 2D-based method, the 2D-based method outperformed the randomly selected model in 2 metrics. Oracle image only outperformed on the EM at 10 metric, but they depend on the Oracle setting of the object location. Next, the 3D-based method used ScanRefer, an object location estimation model, to estimate the location of the object in question, and then used an image of that location to answer the questions. The results showed that ScanQA was superior on both measures. This shows the results of the ablation study. The ScanQA model outputs 3 results: answer, object category, and object location, which are learned simultaneously. Therefore, the ablation study investigated which modules affect the accuracy. Finally, we realize the accuracy of M at 1 is 12.16% by only answer module, 18.31% by answer and object category module, 20.46% by answer and object location module, and 23.45% when all modules are included. This indicates that all 3 modules contribute to the accuracy of question answering and are important modules. Finally, the results of the quantitative evaluation are illustrated in the figure. From left to right, they are the results of ScanRefer plus McCann, ScanQA, and ground truth, showing the answer and object localization results to the question, what is on the wall above the backpack, in a certain environment. ScanRefer plus McCann estimates the position of the object as the display on the desk, and the answer is also wrong as a picture, whereas ScanQA estimates the position of the object as the backpack. Bounding box is slightly off from the correct value, but ScanQA returns the correct object position and answer. We believe this is because ScanQA learns the object position, answer, and object category at the same time compared to ScanRefer plus McCann.